Hello everyone, today we are going to give demo of a project that is generating artificial faces using GAN. Generating artificial faces is a popular image synthesis technique based on artificial intelligence. It is more powerful than traditional image-to-image translation as it can generate images without given paired training data. The goal of generating artificial faces is to capture common characteristics from a collection of existing images and to figure out a way of enduring the other images with those characteristics, examples, shapes, and styles. Generative Adversarial Networks, GANs, provides us an available way to implement generating artificial faces. We need AI-generated artificial faces in various fields, such as creating faces for the players in video games that are actually non-existent in the real world, and in various Instagram and Snapchat filters. Generative adversarial networks, in short GAN, are the effective ways to train data for computer vision-based application. Moreover, it can be used to create a synthetic dataset to fulfill the requirements. Generating high-resolution images is a challenging task because the generator must know the details and structures involved in images. So the problem statement of our project is to generate artificial faces using GAN. The existing systems are trained using small data sets, and therefore the discriminator can be fooled by adding just a little bit of noise in the data. We are using GAN, which has two deep neural networks which make it possible to train the system with a large data set. Hence, the discriminator tries to make a correct classification. So now I'll tell you about the relevance of our project. So generating artificial faces is relevant to the following fields: generating examples for image datasets, generating photographs of human faces, generating realistic photographs, and in photograph editing and face aging.
So now the objectives of our projects are: the goal of the project is to generate high resolution deepfake images, and the solution which we have given for this problem is using GAN by training the network by progressive adding layers. So the main objective of our project is to generate data that is indistinguishable from the real data, whereas the discriminator takes both real and generated data and tries to classify them correctly. So here is the proposed system. Here you can see in the diagram is an overview of our project where the generator takes in random numbers and returns an image. And then this image is fed into the discriminator alongside a stream of images taken from the actual data set. So now the discriminator takes in both the real and fake images and return probability, which is a number between 0 to 1, with 1 representing a prediction of authenticity and 0 representing fake. The main purpose of this project is to generate high resolution, fake realistic images. And the project which we are developing can be used in various fields such as text to image translation, photograph editing, face aging, generating cartoons from fake realistic human faces. Another popular implementation of GAN is to generate emoji from real faces. This is implemented in a popular application called Bitmoji, which is used by various Snapchat users.
So yeah, so we are using the development tools. So for the development, we need a hardware which must have a processor of 64-bit with 4 cores, 2.5 gigahertz minimum per core, RAM 8 GB, hard disk 10 GB for model training and dataset. Software operating system should be Windows 10, or you can use any other Mac OS. Language should be Python, and platform is Google Colab. So we will talk about the implementation now. So according to the algorithm, for number of training iteration, we will keep a mini batch of M noise samples from prior noise dataset. Sample mini batch of M examples from data generating distribution. For this, I will show you our code where we have implemented this. So here we have created a generator which contains, it's 1, 2, 3, 4, 5, 6, 7, 8, 9. So we have 9 layers. First layer is for the dense. Basically, what dense is does it specifies the input size. So we are using a 128 into 16 into 16 is basically a three RGB colored image, and after that we are reshaping it into the 16 16 128 to get it according to our model. After that, we are adding these four layers. These will be the neural networks. Okay, and we are generating this model. Similarly, we have the discriminator, which will predict whether the images are real or fake. Here we have added 1, 2, 3, 4, 5, 6, 7, 7 layers. So basically, let's start from this. Convert 2D is taking an input of image size. Similarly, this one and all these layers. These are considered as the neural networks, and we are using a sigmoid activation function. For the optimization, we are using RMS probe. So basically, it is to check the accuracy and all. We are using this, and hence we are the discriminator. This is come under discriminator. Okay, let's go. Okay, so we are using a data set which is celeb attribute celeb data set. Okay, so basically this is our data set. In this, there are 2 lakh of images which are of particular size, and we are training our model on these images. So as you can see, images are 512 into 512 of the resolution, and we are resizing it in this. Performance metrics. For performance, we are using precision. Precision is the ratio of correctly predictive positive observations to the total predictive positive observations. The question that this metric answer is all of the passengers that labeled as survived, how many actually survived. High precision relates to low false positive rate. We have good to 0.78 precision, which is pretty good. Recall. Recall is the ratio of correctly predicted positive observation to all the observation in actual class. The question recall answer is, of all the passengers that truly survived, how many did we label? We have good to recall of 0.613, which is good for this model as it is above 0.5. So let's talk about the result and discussion. Okay, so now we will run this code, and we have placed our data set in this folder. So it will take 10,000 images of the start to train the model, but we have 2 lakh of images. So it will take the random images from that. So after that, we are cropping to the actual size because there should be some images which can be of different sizes. So we are specifying the exact size here. Okay, let me run this. Okay, so our code is running now. So we got all 10,000 images. As you can see, these are some of the image samples that our model took from the dataset. So it will take some time to train the images. We have to wait. Okay, so as you can see, our model is getting trained on the epochs. So for the epochs, we are taking 15,000 iterations. So our loop will run over 15,000 times to get the accurate model. So at least one step took at least 17 to 18 seconds. It depends upon the GPU and the CPU you have. So for the time being, it took at least, but we trained the model overnight. So you can see the losses and everything. Our trained model will be saved under the name of GAN.h5. So h5, it's basically a model which is given by the TensorFlow. So this h5 model, we can use it anywhere. So regarding the output, we will get these kind of images. These are randomly generated images, which are basically merged, features are merged with the different images. As you can see, if you want to see the difference, you can see it here. As the images are a bit of low resolution, so you won't be able to get the difference. So that's our model. Yeah, thank you. So we talked about the results. So yeah, so we gave these as the input images, and we got these as the output images.
So we have shown that the output is in the form of a GIF in order to make sure that everybody is understanding how we are merging the features and then we are producing it. So the conclusion is that GANs and generative models are very fun as well as perplexing. They encapsulate another step towards a world where we depend more and more on artificial intelligence. And we know that, as we have seen earlier also, that we have a huge number of applications in generating examples for image data sets, generating realistic photographs, text to image translation, face aging apps. So we see how progressively adding the layers helps the generator function remain stable throughout the operation, as well as generate a reasonable image. So this opens a new potential, and more advancements are here to come. Thank you.
Thank you.